All right. Now there are a couple of special logarithms. Sorry about those. Logarithms that are utilized, I guess you might say, in applications more than others. One way to put it. And so they're given their own special notation. First one's called the common logarithm. You know, logarithms can have any base, positive, besides 1. Logarithms can have any positive number base. Well, the common logarithm is specifically the logarithm base 10. And it's denoted just as the log of a number, x. Now, what's special about that? Why is that special? LOG. Notice what's missing here. Yeah, there's not a number base there, is there? So if we don't see a base in our logarithm notation, the base is base 10. It's the common logarithm, okay? So no base showing on LOG, but it's understood to be 10. Okay, understood to be base 10. So if I have log of 1 million equals 6, and it asked me to convert that to exponential form. Well, exponential form, you need to start with a base. Well, there's not a base. I can just choose any base? No. With LOG, it's base 10. So this is 10 to the 6 equals 1 million. That's what we're saying. This base is 10. Okay? Number 2, special logarithm is the natural logarithm. We spoke a little bit about the natural base last time, and what did we say the natural base was? Did I mention that word? Natural? Oh, I did? Oh, never mind then. The natural logarithm is the logarithm base e. Common logarithm base is 10. Natural logarithm is base e. And the natural logarithm is denoted ln of x. Again, there's not a base there that is shown, but with this notation, ln, hence natural logarithm, probably the reason for that, there's no base showing on this one, but it's understood to be base e when I see the ln. The understood base is e. We see ln, it is understood base e. And so if I have ln of ln of 25 equals 3.218875825. That's not the end of it. That's what my calculator shows. What's that in exponential form? Well, again, there's not a base showing, but in exponential form, this is base e. Or it is base e, and then so in exponential form, I put e to 3.218875825 that equals 25. All right. Well, suffice it to say then that ln's of numbers are not going to be nice whole integer numbers. The good news is the calculator will do these for us. We can most calculators will evaluate common logarithms and natural logarithms on the calculator. Scientific calculators. Most of them have both. Yeah, my little TI-30 here has both the common logarithm and natural logarithm. So we don't have the problem. A while ago we said natural, the log base 2 of 30. I don't know what that is, but the common logarithm of 45, that's not going to be a nice number, is it? That's 10 to what power is 45? 10 squared is 100. 10 to the first is 1. 10 to the squared is 100. So I've skipped, so to speak, nice powers. There's not a nice power of 10 gives me 45, but the calculator will do that for me if I can figure out how to work it. All right, 45. Yeah, the LOG button should be on your calculator there. It's 1.532. ... Okay, how many ever you would like. So we can evaluate common logarithms. We can evaluate natural logarithms, which is what I did over here. What is the, somebody tell me the natural logarithm of 750? Anybody got natural log? 6.62. Yeah, so it's easy enough to get those. Okay. All right. All day long we can evaluate those, and we will definitely be using those much down the road.